Okay, welcome everyone. While we're waiting for people to join, I'm happy to take any questions if there are any that came up recently. Well, if not, let me begin by with an announcement. We have an additional teaching assistant in this class. It's Kutai Masid. Do you briefly want to say hi, Kutai? Is it just me? It's just me, or can't I? I can't hear you, Kutai.
Uh, can you hear me now?
Yes.
Okay. Hello everyone. So I'm Kutay Majid. So I am new teaching mentorship for this class. Um, so I am happy to be a teaching mentor for this class. And yep, see you like for the office hours. My office hours will be probably at Mondays, but I haven't decided for the hours yet. I will let you know for my office hours later. Yeah, that's all.
Okay.
Yep.
Thanks. And also an announcement that I had to move my office hours up today. So I think they'll start at 2:30. Check out the calendar. I have a conflict at my usual later slot. Great. So today we'll be talking about basic Python 2. That basically means we'll talk about data types, operators, if conditions, loops, list comprehensions, and functions. Um, and this will give you kind of all the tools that you need to complete homework one. Like a majority of the stuff like you could probably have done already, but today we'll cover everything that you need. Great. So let's start off with data types and operators. See. Um, So we've covered some basic data types and operators. So we did talk a little bit about numbers and about string types and so on. But now let's introduce all of the ones that we really that we'll need. We'll recap some of them and go into more details. Of course, like I'm always trying to link to the complete documentation of to official documentation of Python, because the official documentation and the official tutorials are pretty good, and it's kind of like the place to go instead of just searching something on Google. So let's start with Boolean. So Boolean values represent truth values, true and false. And of course, they can be used like any other variable. So here I'm assigning true in like it's in capitalized in Python, only in capitalized. So the lowercase version does not work. You can already tell that by it doesn't syntax highlight. So the capitalized version, I can assign that to a variable, and then I can print that variable. And similarly, I can do the same thing for false. So that's not particularly surprising here, but yeah, this is how that works. Um, there are three operations defined on Booleans. These are these logical operations: and, or, and not. And of course, if I have uh, the or operation, then the result is like if x is false, then y else x. If I have the and operation, if x is false, then x else y. And if I have the not operation, I'm inverting the truth value of that variable. And so here's a demonstration. What's the result of true or false? It's true. True and false is false. Not true is false. Not false is true. Okay, so that's easy. Now let's move on to comparisons. Comparisons are, so, of course, very important in programming because they let us decide on kind of like flow of a program. We need kind of comparisons whenever we write a while or loop, or when we do like an if statement or anything like that. And so to make comparisons between two entities, Python provides 8 different comparison operators. They are the strictly less than or equal, strictly greater than or equal, equal, not equal, and then 2 ones about object identities. And so we'll not talk about those today, but we'll cover like mostly the numerical or the logical ones at the top here. So these operators take two operands and then return a Boolean. So if we do 1 smaller than 2, we get a return value of true. If we do 1 smaller than or equal, then we get true. 14 equals 14. True. 14 not equal 14 is false. I can also do this comparison with strings. So I can ask for, is my text equal to my text? And that is true in this case. And you can see that it actually does like a comparison. It's not just a comparison of, is this a string object, but it actually does a comparison of the content of the string. I can do things like comparing strings by lexicographic order. So I can say A is like the string A is bigger than B, which is false, or the string A is smaller than B. So that's also something that not all of the programming languages can do out of the box. And then if I look at how it works, it basically does like a matching by the order. So AA is smaller than ABA, and AAA is like here the shorter string is the kind of like smaller value. So this kind of shows us how these operations work, both on numbers and on strings. And strings are kind of like very convenient. They use like lexicographic ordering. So like we also have, like I already mentioned this last time, but we have numerical data types, 3 exactly of them: int, float, and complex numbers. And Python is what's called a dynamically typed language. So I don't have to define a data type ahead of time. So for example, if you do C, you would have to say int my variable name. That's not what you have to do in Python. You can just like define a variable and use it. So that data type is automatically inferred. And integer is the data type that we use to represent all real numbers. And Python is kind of like unique in a way that how it handles integers, because it can handle arbitrarily large integers. Like most programming languages like C or Java have like 32-bit or 64-bit integers, and then you have to kind of like make sure that your number fits into that address space. But Python doesn't do that. So I can do things like this in Python, which would be like an overflow in almost every other programming language. So this is like a huge number. However, in practice, this is true for the native data type of int in Python. We will be using like a lot of like NumPy, which is kind of a library that is built on top of Python, which is kind of like more efficient. But NumPy again uses like actual data types that are like implemented in C. So there we have these limitations. So this limitation just doesn't hold for the native data type. But if we use NumPy, we can still experience overviews in Pandas or in NumPy. So integers can be positive, 0, or negative, as what you would expect. And so the second data type that I want to talk about is the float data type. The float data type is used to represent real numbers. However, floats cannot be precisely represented by a computer. So like, I don't want to go into the details here. And this isn't going to be exactly correct what I'm saying here, but it's kind of illustrative. So for example, if I wanted to represent the number that is the result of 1 divided by 3, that would actually require the computer to store an infinitely large number of 0.33333 here. That is, of course, if the computer did actually use a base 10 system. It doesn't. It uses a base 2 system, but illustratively, this still works, right? So what the computer does here is it doesn't store this number precisely. It doesn't store the expression of 1 divided by 3 or 1/3. It uses instead an approximation of this floating point number. And so that sounds like I'm talking about something very behind the scenes here, but this is actually practically relevant. So because computers can't accurately represent a number like this, even not a number like a seemingly simple number as 0.1 is not accurately represented in the computer. It's always kind of an approximation, right? And the consequence of this is that, like, what would you expect, like not thinking about a programming language, but just as a mathematical expression, this here should of course be true, right? This is kind of like I'm comparing 0.3 to 0.3. But if I do this like this, it is actually false. And so anybody like have an idea why when I'm explain that?
It's because of a round off error, right?
Exactly. So the kind of like what is actually stored behind the scenes is rounded, and so therefore we can never assume that these two values are actually identical. So they might be identical by accident, but you can never assume that they're identical. And this is like a very, very common problem for like beginning programmers, that they kind of like try to do an equality test with a floating point number, and then they print it and they look identical, but in fact they're not identical, right? So you have to be really careful. So if you do something like this, Python shows you 0.1, but behind the scenes, like this is actually something, some kind of magic that is happening. So Python kind of like understands, like you want, this is what you care about, right? But behind the scenes, it is stored like this. And that's not all that useful for like almost all intents and purposes, but it shows you that for floating point numbers, you have to take care. You have to take care about like not trying to use equality. I see a question here. If I do 1 divided by 10, or yeah, so any kind of like floating point number will have that issue. Or does that answer your question? So anything that is not an integer will have that issue. So you can't do this. So what do you do instead? Here would be kind of like what you could do instead, although this is a little bit tedious. I can say, I can ask to compare equality up to a constant value. I can say a smaller than b plus 0.0001 and a bigger than b minus 0.0001. So this is kind of like a way of testing rough equality, right? So an expression like this will be true. However, this is not all that comfortable. I also have to kind of like specify precision, but this is kind of like the way you would do it. You need to, like, if you talk about floating point numbers, you need to say, are they equal up to what point, right? That is kind of like the decision you as a developer has to make. And of course, it matters the context. Like sometimes if you're like, don't care about precision, this might be totally fine. If you're working with very small numbers, you might have to use a different value for these comparisons here. This would be kind of like implementing this manually, but there is a function in a package, in the math package, that does something like this. So 2 things here are noteworthy. Like here is an import statement. This is the first time we are using this. An import statement tells Python, like Python has some base functionality, things like operations, additions, some like functions, and then there's some standard functions that Python always comes with, but everything else you add to a program dynamically. And so here with this statement, I'm adding a lot of math stuff to kind of like the available language that I have, the functions that I have available. And so if I do that, I can like import math, and we'll talk more about like nuances of importing later. But now for now, basically just know that I have now math stuff available. That math stuff is available in the math namespace. So I can say now math.isClose. And isClose is a function where you pass in 2 parameters, and then you can pass in like a relative tolerance. There's a default relative tolerance, but here I'm kind of like putting in a relative tolerance, and this will work just as I would have hoped. Okay. I mentioned earlier that Python is a dynamically typed language. So for anybody who has worked with other programming languages that are statically typed, you might be used to defining your types. And you can now do type annotations in Python, but they are kind of like more for like the kind of like making sure that your program is readable and that you can do automatic tests so that you can make sure that it's quality controlled. But you can do type annotations. So here, this would be kind of like a type annotation. I can say greeting is of type string, and then I assign a string to it. Then I can print that. But Python doesn't enforce that, right? It doesn't throw an error if I assign an integer to that. It will just change the type. So this is kind of like useful to understand if you see that's in the syntax, but I don't really expect anybody to write that. That is more if you want to do some kind of like software engineering with where you would also like write a library and you want to run tests on it so to make sure that it's correct, then you would do something like this. It's also sometimes useful to hint at the return type of a function. So we talked about functions last time. We talked about that they have return types. Here I'm kind of like passing in, like here I'm type defining or type hinting at what I would expect for the name, so a string. And this here tells us that this function is supposed to be returning a string. Again, like this works just fine. Again, it doesn't really enforce anything, so it's really more about kind of like making very explicit what you're trying to do. Okay, so let's go back and talk about numerical operators. Like numerical operators are the kinds of operators that we're all familiar with. So we have addition, we have subtraction, we have multiplication, we have division. Some of you might not know this operator. This is the modular operator. In line 22 or in box 22. How do I know Python? How does Python know 3 is a number, not a chart? Well, it if it because I'm specifying it as a number, right? If I did this, it would be a string. By the way, char is like a single character data type that doesn't exist in Python. Do we use type? We can use type to check a number. Yeah. So if we do, if you do this here, I'm expecting type of greeting to be integer. Okay. So continuing with the operations, the modular operator is kind of like the remainder, like it's x divided by y, and what is the remainder of that? And that is sometimes quite useful. And so I'll be using it a couple of times today. We can negate number. We can get the absolute value or the magnitude of x. We can convert a number to an integer. We can convert a number to a floating point number. We can do like a power expression with a function call, or we can use an operator with the 2 stars here to do a power operation. So all of these are fairly straightforward. Here's the modular operator. 7 modulo 2 would the result be 1, because it's like the remainder of the division by 2 is 1. In many programming languages, we have shorthand operators, and the shorthand assignment versions. So for example, if I want to do this, like add 2 numbers and assign them to a new variable, like I have at first defined 2 integers, x and y, and then I'm redefining x to be the sum of x and y. And that is fine, but I can also write this here. So x plus equals y, and that means x is x plus y. So the left-hand thing is added, like the right-hand thing is added to the left-hand thing with this expression. And this also works for other operators like a subtraction or a division, or even like a power operator. Okay, so these are the basic operators that we have for the numerical data types. Now I want to talk a little bit about functions. And so we've used functions before. We talked about functions. We defined functions. We talked about how they, like that you have to do an indentation to make clear what is part of the body of a function. So just to recap, they have a name, they take parameters, they may take parameters, they don't have to, and can, but don't have to provide a return value. An indentation is what distinguishes the body of a function from the surrounding code. So here we have a function that essentially just like doesn't do anything all that sensible. It just adds 2 numbers, but just to show how that syntax works. Also remember, this is super important, scope in functions. So for scope, remember that we can like whatever is intended, this is kind of like the scope we have. So here, this function scope variable that I'm defining is only readable within that function. So in here, I can actually read it. As you can see, only readable in here. if we did this, this would throw an error because this statement here refers to like a variable that's only defined within that function. And so this will throw an error. So this is not like something that you can do. And we talked about that this is useful to keep your like functions modular. So what is happening inside a function shouldn't be your concern when you use it. And so you shouldn't have any side effects of a function. And that's why we use this kind of like scoping here. Functions can also be given default values. Like we're probably not going to do that all that much if you write our own function, but we'll can use non-local instead of global if you want to use it out of a function. I don't think that non-local is a keyword in Python. But we can try. Very non-local. Oh, it's actually defined. So I'm not sure whether it will work. But yeah, it's like you should neither use non-local or global in practice. Okay, so default values. Default values are kind of like sometimes useful, especially if we have like a library, for example, like pandas. If you have functions that have like 30 parameters where you can set like many different things, it's often like you don't want to like necessarily specify every single one of them. And so to avoid that, you can give a function parameters. You can give them default values. So here I have an example where I have 3 strings, A, B, and C, and I'm just printing them here. And I'm setting them the default value of an empty string. And so now I can do this. And this here, like by default, if I don't do anything else, any kind of like call will be by position. So print vars here, because I'm passing only along a single parameter, it will take the first one. It's independent of whether this is called A. I could have something else in here, right? So this will call like for the first parameter. So this will like print it first here. Now, if I want to be explicit about which of these parameters I want to set, I can do this. I can say B equals B. So that will work. So you can see that I have like a little space here because this is from the print function. So there was no A, but then I have B. No, this function does accept anything. I can pass in something else, but then it might, well, this is going to work. So it just says the default data type here is a string, like an empty string, but I can still pass in anything else. The nice thing is that I I don't have to follow the order, right? And if I have a very long, list of parameters and I only need to specify one, this is the way to go, right? This is very convenient. I can also do these explicit assignments out of order. So I can do like C is CC and A is AA, and I don't have a B value here. So this is also very convenient if I have complex functions. And sometimes it's even easier to, like, even if you don't need it, even if you're doing it in order, this is kind of like a nice way of like if you have a complicated function call of making your code readable, right? If you just like want to, let's say, read a file, you can say file name equals, and then you have like some kind of string path or something like that. By doing that, it is very explicit of what you're passing in which order. Okay, another thing that we can do with function calls in Python is we can have functions with arbitrarily long arguments. So we've actually used a function like this here, the print function. I can put in A, B, C, but I can also add, but I can also keep adding elements here. I can say test, and that is fine. So this is kind of like a function of with an arbitrarily long set of parameters, and I can specify a function with like this leading star here. So if I do that, I get this here. So behind the scenes, this is a tuple, like a tuple, kind of like a variant of a list. We'll talk about this in the next lecture. But just so you know, I can pass in, like here, I don't actually define a tuple, right? I'm actually just passing in a list of parameters. Okay, any questions about this? Well, great. Then let's keep moving. Now we'll talk about conditions, if, elif, and else statements. So you've all probably, certainly you have seen if statements. They're super important, of course, to steer the program flow. Let's look at how this looks like in Python. So we have this, like here is, I'm defining a function just to call this easily. In this function, I am setting like if x modulo 2 equals 1. So I'm testing for whether like this is odd or even. And now I use similarly as for the function definition, I use indentation. And then in this body, everything that is indented here is actually executed if that condition is true. And so here is like the first time we're using such a kind of like a comparison statement in a control flow. And so if that is true, then this is executed. If this expression here is false, this is executed, but only if this is false, right? So this is like, it's either this or that. And if I now run this for two different values, my is odd for 144 and 13, I get like 144 is an even number. So this is the second branch here, and 13 is in fact an odd number. This is the first branch here. No, like the question is, does x have to be an integer for modulo to work? It does not. So, well, that did some kind of weird coercion here. So modulo, like that's a good question. I'll have to look this up, but I'm assuming that the modulo operator just does implicitly a cast to integer behind the scene, but it looks like you can pass in a floating point number, but then it does like a cast to an integer. So it doesn't have to be an integer, but it is kind of like made into an integer. Okay, so one thing that you might notice here is that I haven't used any parentheses around here. I can like this is equally fine, and you will sometimes see me do this, even if it's not like particularly useful or important. Is actually not the way Python is supposed to be written, but a lot of other programming languages do it like this, and so I kind of tend to sometimes do this intuitively. But you don't need the brackets. The brackets are useful for kind of like use it for defining some kind of rules and some preference, but that you don't have to do something like this. You can just do this, and this is kind of like the more Python way of doing it. But of course, sometimes like if you want to make sure that like you can use logic and use kind of like preference, you of course want to use parentheses. And so you could write something like that. And again, like there's no like no need to do like some overarching parentheses here. You can do it. It's going to have the same result. But yeah, that's and I personally recommend that like I'm not talking explicitly here about like each of these operations have kind of like a well-defined order of preference, right? So in this case here, like an operation, for example, like an equality test has preference over like a Boolean operation. There's very clear rules in Python, so it's well defined. But I would recommend that you just use parentheses to make it explicit on like what is the order of evaluation that you want to do if you have more complex expressions like this. And so what we've done so far is we've used only explicit Boolean values, true and false, or kind of like the return of an operation that gave true and false for steering conditional flow. But kind of like every programming language that I'm aware of has like a notion of what value is truthy and what value is falsy. And by that, this like, of course, the Boolean value true maps to a truthy value, but also other like values in certain data types map to true. It's easier to define this as false. So like what is considered false in an if statement? The Boolean value false, obviously, that's what we've used so far. Exactly 0 of any numerical data type is also considered false. So if you say if 0, that is the same as if false for all intents and purposes. If you put in an empty list or a sequence, like an empty string, then that is also considered to be false. So like, if I did, well, there's examples here. So an empty list is false, or an empty string is false. And then similarly, I have like none. This is kind of like no value, not zero, not false. It's just no value. That is also considered false. And so here's a list of examples. So if we run this, if 0, that is false. So we get into the else statement. So this should never happen. 0 is false is what happens here. We have an undefined variable, if not undefined. So I'm negating it here. So then we should see an undefined variable is false. If not, an empty array, and we'll talk about arrays or lists later. An empty list is false. I'm negating that. And so therefore this here is actually executed. And similarly for if not string, I'm negating the empty string, and empty string is false. Okay. We can chain conditions using the elif statement. A panda is not a number. I'm assuming that it will also, like a panda's value, like any number in pandas, like a 0 will map to a false, and a not a number will also map to a false. Okay, you can chain multiple conditions using an elif statement, which is kind of like the short form of else if. And so here, like I'm doing like I'm looking for factors of a number x, and I'm trying out if x is a factor of 2, if 2 is a factor of x, if 3 is a factor of x in the elif statement. So I first test for can I divide x by 2 without a remainder? That's kind of like what the statement here does. If I can't do that, I try else if I try whether I can divide x by 3. And if there is no remainder, I print that. And then finally, I have an else statement. And so you can see if I run this on 4, 9, 12, and 13, I get 2 is a factor of 4, 3 is a factor of 9, 2 is a factor of 12, and neither 2 nor 3 are factors of 13. One thing that it's notable is that like elif is like, if this here is true, this is not executed, no matter whether this is true or not, right? So after I have met one condition, I am done with that if statement. So this here for 12, both of those would be right? So, but for 12, I only get 2 as a factor of 12. I don't see 3 as a factor of 12 here. If I wanted to do that, I would have to write separate if statements, right? So here I'm testing this explicitly. If 2 is a factor, if 3 is a factor, and then I'm doing my kind of like else statement explicitly. So just to be explicit about this. Okay, that was it about conditions. Like it's now almost 1, and so we'll do our 5-minute bio break now, and I'll meet you back here at 1:03. Okay, let's continue. Next, we want to talk about lists. So far, we've only worked with basic data types like Booleans, numbers, and string, but now we'll look at a compound data type, and these lists are clearly the most important compound data type. So like a list is a collection, an ordered collection of items. You might also like know the term array. There's in many programming languages, there's a difference between what is an array, what is a list. Not so in Python. This is like just one thing, and I'm usually calling them lists. So lists are created with square brackets and can be accessed via an index. So here I'm creating a list of members of the Beatles, and I'm adding like the index here in the beginning, so it's easier to print them. These are strings. And if I print the whole array, I get like I get this kind of an output, and so the square brackets here tell me that this is a list. But then I can, of course, like access individual elements of an array or a list. And I do that by specifying the index. And so Python, like most other programming languages, but not all other programming languages, is zero-based indexing. So this is index 0 here, this is index 1, this is index 2, this is index 3, and so on. Now, if I wanted to access, let's say, the third element at index 2, this is the way I would do that. I can also in Python, which I can't do in all kinds of programming languages, I can also access elements from the back. So I can say, give me the last elements by passing in index of -1, or give me the one but last element by passing in index of -2. So that's convenient sometimes to use. If we do try to address an index outside of the range of an array, we do get an error. So this is like an index error. List index out of range is a very readable error message here. That is, of course, like a source of bugs that sometimes happens. And then sometimes you, like in C, for example, you have to, if you create an array, you have to tell C how big an array is. In Python, you can just add elements to a list dynamically, but sometimes it does make sense to pre-initialize an array of a certain size. And you can use like a shorthand operation like this here. So I'm saying basically here, take a list of zeros and multiply it by 10. What this means is create a list of length 10 with all zeros. So again, something that looks very unfamiliar in other programming languages, but it's just like a very, very convenient way of expressing it. There is also this range function, and the range functions are rules to how you kind of like step over elements. And we'll talk a little bit more about this later, but this is kind of like also a nice way to create lists with certain rules. Another thing that is super interesting and important in Python are slicings. So there's this, we can slice arrays with the slice operator. So for example, we can say A of start to end. So this kind of like, like we can specify which chunk of a list we want to have. So this gives us explicit, like starting at index start and going up to, but not including index end. Or I can say start to the end of it. So I can say like from the second element to the rest of the list. Or I can say from the beginning to a specified index. So here I could say, for example, give me the first 3 elements by putting in 3 here into the end variable. Or I can use this here to make a copy of the whole array. So all of these slice operators actually don't modify the array, but they make a copy of the array, which is kind of like useful to know that your original array remains unchanged and that you have to maybe override the variable assignment if you want to reuse it or something like that. There's also a step value. So you can say, give me all of the elements from start to end, but only give me every second one or every third one or something like this. There's like a linked post here that explains this in more detail, but just some intuitive examples. So this gives me the first 2 members of our Beatles array, like from 0 to 1. It doesn't include the last index here. And then if I wanted to get like from index 2, including the index 2, which is the third element, to the end, I could use something like this. And then I could create a copy of the array. I'm not going to see a difference here, but this is in fact a copy of the array. if I do like, remember that if I use an index outside of the valid range, I get an error. But if I use a slice outside of an range, I don't get an error. I get an empty list. So that's slightly different. This does make sense in certain cases. Just like as a side note, you can do many of like strings are essentially arrays of characters. There's some special stuff about them, but that's how they are represented. So I can do slice operations like this on strings. So from 0 to 4, that gives me just the first name of Paul McCartney. Strings are not mutable, so I can't change a string once I have defined it. But of course, lists are mutable. So we can, for example, say that John Lennon at some point really became one with Yoko Ono, and we just called him John Yoko. And like if we do that, we can modify our list here, and now we have changed John here to John Yoko. This, of course, as I said, strings are immutable, so this will return in an error. I can't just change one single character in a string. Lists or arrays can be extended with the append function. So if I wanted to say George Martin actually is a Beatle, in my opinion, I can add the George Martin just using the append function here. And then I can do concatenation, so like merging of strings with like a plus operator. So let's say I have Led Zeppelin members here, and then I want to create a supergroup out of the Beatles and Led Zeppelin. I could do a concatenation of these two lists, and would have like one long list with all of the band members of those two bands in my list. I can check the length of a list using the len function. So this is a little bit different from some other programming languages where you have list.len, for example, or length. In Python, you would use the len function for that. And that gives me the result. So the length of my Zeppelin list is 4. And lists can also be nested. So I can have a list of bands that has lists in it. And so here, in this case, I have my nested list of the Beatles and of Led Zeppelin. In fact, lists can also be of hybrid data types, which is something that you shouldn't do generally. So for example, I can say my bad bands list is a list of my bands, and then I create a list with like an integer, a float, another integer, and then a string. And so that's generally not something that you should do. We'll talk about objects that are useful, that are better suited for representing data like this in the future. Generally, like try to really keep your lists of a single data type and of like one single semantics. If your elements of a list have different semantics and different data types, you should probably use a different data structure for that. So these are like the built-in lists of Python, which are very handy. But like NumPy is this library that we'll be using a lot because it is really great for scientific computing. All of kind of the machine learning libraries that we'll be using understand NumPy. Like NumPy is what backs Pandas, which is the big data wrangling library we're using, and we'll be start introducing next Tuesday. But so it's useful to understand what are the differences between a NumPy list and between regular Python lists. So first, I do another import here. I'm actually like redefining the name NumPy as NP, which is very common. I create a NumPy list in this way. So I say numpy.array, and then I can pass in an array. There's other ways of creating it, but this is one of the ways. And all of the slice operations work just the same in the indexing. The big difference here is that the data type is actually not a regular Python data type. So this is like an int64 that tells us this is like a 64-bit integer. So here, in this case, that means we can't use arbitrarily large numbers. We have at most 64 bits. We might run into overflow issues. The reason why we use these limited strings in NumPy is performance, right? If you have like well-defined chunk sizes in memory, you can write faster code. And if you do machine learning with big data, it is important that your stuff is fast. And so this is why we're using NumPy for all kinds of computational things. NumPy also has a lot of additional functionality, will be like, I could say something like numpy.average or mean or median or anything like that. That this is all like pre-built into NumPy arrays, which isn't pre-built into standard Python arrays. But I'm not going to introduce the stuff. We'll just introduce it as needed when we need it. And then one significant difference is that this, what I mentioned earlier, that you shouldn't do is actually enforce that you don't do in NumPy. Also before performance reasons. So I can't do hybrid arrays in NumPy. So what happens here, if I try to do this, I have an integer and then strings, is that behind, like, NumPy tries to initialize it, but then finds, oh, this is like different data types. And so I'm just going to convert everything to the common denominator. And since I have a string in here, a string is kind of like the most kind of like generous data type. And so it converts all of those here to strings, and these are not numbers anymore. And so that's probably not what you want to do. Okay, these were NumPy arrays, very similar largely, but with slight differences that you have to be aware of. So now I want to talk about, like, we've talked about conditional statements, we talked about functions. Next, I want to talk about loops, because loops are like super useful to iterate over stuff. And we'll talk about two types of loops, for loops and while loops. And while loops are a little simpler, so we'll start with while loops. And a while loop is essentially, like, I'm using again a block statement, the while keyword, then an expression that is evaluated for truthiness, then my colon, and then my intended block here. That is the body of the while loop. And so here my expression, this is kind of like the important piece. This loop keeps re-executing the stuff that is in the body until that condition is violated. So until this evaluates to false. And so initially I have a equals 1 here. And then here a is smaller, like 1 is smaller or equals to 100. So this is going to execute. And then in here, I have to make sure that I change a in a way that this will eventually terminate. So like I'm only printing a here with like a, yeah, I'm just changing how it's printed a little bit. You can look at this if you care. And then here I'm adding 1 to a. And so if I execute this, I will get like a list of, basically like a long list of numbers from 1 to 100. So this executes 100 times. And then eventually a is 101. And then this simply like terminates, or this block is not used anymore. And then our program here terminates. I can do, well, an a multiplied with 1 wouldn't be all that smart, but I can do a multiplied with 2. That would also work, because if I just multiplied with 1, I would kill my kernel. I would have to kind of like hit stop here and restart everything. That is kind of like the big thing here. So if you did actually, like, the question here is, how about if I do a multiplied by 1, you would have written a while loop that never terminates. And here's like the simplest while loop that never terminates. I'm simply saying while true, print stuck. And this will print stuck until your computer runs out of memory, or until you terminate it in some other way, or yeah, whatever happens, something that is not part of the program. This will just keep printing stuck. And of course, this is something that you need to avoid. And it's not always going to be that easy, right? Like, obviously here it just never terminates, but sometimes you have some more complicated conditions, and you have control flow within the while, and you might not actually, in some certain conditions, you might not terminate your loop. But that's something that you have to be careful that you don't do. You can do like a while true, and instead of like having an explicit condition here, you can use a break statement to terminate the loop. So for example, if I have some complicated logic, maybe I want to just do something while true and then do something more complicated in here, and then execute my break statement explicitly, and break just terminates the block and continues with like stuff that happens after that while loop. So it's kind of similar to a return statement of a function. The other thing that you can do is you can use the continue statement. And so continue essentially tells the loop to end this particular run in the loop immediately and continue with the next one. So here's an example. So what I'm doing in this loop here is I want to, like, I'm going to show you the result of it. I want to put like square brackets around every number that is divisible by 3. And so how do I do that? I could do this with an if-else statement, but I can also do this with a continuous statement. So here I am like using this like modulo operator again to check whether it's divisible by 3. And if it is divisible by 3, I'm putting like, here are the square brackets that I'm putting around it. And the other thing that I'm doing here, which I probably haven't introduced yet, I'm using what's called a formatting string. The formatting string here is like I'm putting this F in front of my quotes here. And then what I can do is I can use curly brackets to kind of like put in variables for my program. So this is kind of like just a convenient way. I could have done this with string concatenation, but this is just a convenient way of doing hybrid like text and variables. So I'll be using this a couple of more times, but all this does here is take A and put the square bracket around it if this condition is met. But the point of this here is mostly that in this point here now, I want to say I'm done with this iteration in my loop. I want to continue, go back up here. If I'm not getting into this statement, this here is executed, and then it just prints a regular number without a bracket. Here's like another example of a formatting string in a kind of like maybe a little bit more readable or more easily to understand. So for example, if I have my variable Alex, and then I say print my name is, and then I can use the curly brackets to refer to this variable here. And that's an easy way of creating these hybrid, like these strings and putting them together with variables. Okay. The next type of loop is the for loop. If you like come from like a C or C++ background, then you're probably thinking of a for loop of like for x is 0, x smaller than 5, x plus plus, or I, something like this. In Python, we typically use for loops to iterate over the items of a sequence. So which is in other languages is known as a for each loop. And so this looks usually like this: for my variable in a certain sequence. And then I do something with my body here. So here's a simple example. For member in our Zeppelin list here, I can print the members of Zeppelin. And so you see that this is like actually, there's no list here. I'm actually printing the individual members. So I'm iterating over the members of an array, and then I'm doing something in the body to it. Of course, I can combine this with arbitrary slices of lists, and slices of lists are just, again, lists. So here I'm simply iterating over the first 2 members of the Zeppelin list. If we have nested loops, like in our bands array, we can use nested for loops. Sorry, if we have nested arrays or nested lists, we can use nested for loops. So I can say for band in bands, then I can do something about for each band. And then I can say for each member in band. So I have now a nested two levels nesting of a for loop. And then I can print the band members here. And you can see that I'm doing this for each list, and I'm doing this here for each member in the second level list. So now, what about if you want to iterate over like index 1 to 5, right? That's something that you sometimes want to do. And the way to do this in Python is to use the range function. Oops, I didn't actually want to click this. So think of ranges as rules that kind of like, they don't really generate a list, but you can think of them as generating a list. They just simply generate something that is iterable. So if I were to like just do this range 5, that it tells me what I think you wanted to do is a range from 0 to 5 with the default step size of 1. So I can just iterate over this. So for example, if I wanted to iterate from like index 0 to 10 or to 9 in that case, I could do this for I in range 10 and then print I. And so this does kind of like what you would expect from like a C++ style for loop. We can also use ranges to explicitly create the list. So for example, I can say, create a list out of my range. But this is not what happens here, right? This is just a rule. This here actually creates the list. similar to slicing, I can my range function can take out like parameters like start, stop, and step size. So I can create like a list from 0 to 10 that has only like that with 2 steps in between them. So then I have 2, 4, 6, 8. And I can do things like with a range function, I can do things like start from 0, go to -20, and use a step size of -3. And then I can print numbers like this here. Do you have any questions about while loops, for loops, or anything like that? Okay, so now I want to touch on one topic that might be a little bit hard to grasp the first time. Like if you've never heard of recursion, you might not have an easy time following what I say here. So like if you don't really get what I'm talking about here, just revisit this, think a little bit about it. Recursion is kind of like the interesting definition is to understand recursion, you must first understand recursion. But yeah, so it's basically another way to control program flow. And recursion isn't something that is, well, it doesn't have a special keyword. It just uses function calls smartly. And so a recursive function is a function that calls itself until it doesn't. And by until it doesn't, this is kind of like where we have our terminating condition, right? You can think of this as like if we have like a condition for a while loop that we terminate, we will have to use something similarly for a recursive function. So here is an example. I want to print the numbers from 0 to 10. I am defining a function that's called print numbers with 2 parameters. This is kind of like my current number that I'm looking at and the limit. Like I want to go up to 10 numbers. And so what I'm doing here is I'm printing the current number. And then here's my condition that I need to check. If current is smaller than limit, then I'm calling this function that I just defined up here again. But now I'm calling it not with my initial initialization of current, but I'm adding 1 to current. But I keep the limit the same. And so if I do that, I can put in, like I can call that function for the first time. And then what happens is I print this as if I had, this prints as if I had like created a loop here, right? Just by like first time this here is called is from here, then this is executed, this prints 0. Now I try if 0 is smaller than 10, then this happens. And now this calls itself again, but now not with 0, but with 1 and just passes on 10 again. And now if I start, now I get back in here, I get the value 1 and limit 10. I print 1, then I check if 1 is smaller than the limit, then I call myself again. So I'm kind of like building up a call stack here. Like these, I think this here is like a good example of, let me see. Well, yeah, so I'll explain what I mean by this. So I can, for example, if I wanted to print these numbers in a reverse, like I'm now doing, what I'm doing here is like, here's the print statement that prints the number. And now I'm moving the print statement from before the if to after the if. But what will happen now is that these numbers are actually printed in reverse. And that's because of how this call stack works, right? So you start off with your first call to the function, but instead of printing something immediately, you go into your next function call and the next and the next and the next. And only if this is done, then will the first function, the deepest function will return, and that deepest function will have the value 10 and will print it. And then it will go back up to the previous function and call 9. And then it will go back up and call 8. And so here is kind of like a more explicit representation of this. Now here I'm printing it, the parameters, every time before and after I return. So you see, before I call, I have like start with 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then I've reached my terminating condition, and then everything like this deep nested hierarchy starts to unwind and go back from 10, 9, 8, 7, 6, 5, 4, and so on. So I hope this makes a little bit of sense. It is kind of like something that is super useful in a lot of cases. For example, if I want to traverse a tree, recursion is by far the easiest thing to do. But it's also useful for other things. So for example, in your homework, we ask you to print the Fibonacci series with a recursive function. And the other thing is, like here, I haven't used the return value. I've just done a blank return. But I can also use the return value. So for example, here, I am I'm kind of like creating one long string dynamically using recursion, and then append it to the existing string. And so that would be like an example where I'm actually using a string. Any questions about this? If you're not sure how this works, what I would recommend is take this example here and draw it out on like a sheet of paper. Like, what is the parameter? And then like just keep nesting it, can keep nesting the calls, and then you'll get it. Okay, so the last topic for today is something that is very specific to Python. It's called list comprehension. And list comprehension is one of those cool Python things that make like data manipulation very, very easy and concise. So list comprehension can be used to initialize and transform arrays. And like here's like my list comprehension expression. So I have my list brackets here. Then I have some kind of expression, and then I have a for statement. And there's for element in some kind of list. So in practice, this is what this looks like. My expression here is just 0. Then I have my for loop. I'm saying for whatever in range 10. And so what this does is it creates an array of all zeros. And note that I'm using underscore here. I could just as well use anything else here as my variable name. It doesn't make a difference. But by using underscore, I am actually signaling that I don't really care about that value. I just want to be able to iterate over that range. So that's kind of like a custom way of doing that, but it doesn't actually make a difference. I could similarly, like 0 is one expression. I could also have an expression that's called John, and then I just have 10 Johns here. But we can also sometimes I might not want to use the variable that I'm iterating over here. Sometimes I might want to use it. So for example, if I do this here, like for I in range 10, I am getting a list where I'm actually using the value. And now I have initialized a list that starts with 0 and ends with 9. Because I'm using the I here, this is the expression. But this expression here doesn't have to be just a variable. It can be an operation or a function call. And so, for example, if I wanted to create a list with 10 random numbers in the unit interval, I could import the random function, the random package, and then call random.random, and then do this for a list of for range 10. And now I get 10 numbers that are like random numbers in the unit interval. I could have written a for loop here, right? Of course, just a regular for loop and appended it to the list. But this is just like a much more concise way of doing this manipulation. And then finally, I can actually manipulate the elements of a list. So for example, if I wanted to actually have random numbers in range 0 to 10, I could take the list that I had earlier and multiply each element with 10. And so here I'm saying for x in rands, take x multiplied by 10, and this is the element of each list. And so if I do that, you can see that I now have like random numbers in the interval from 0 to 10. Okay, so that was the content for today. For the rest of the 15 minutes that we have, or 13 minutes, I see there's a question, how can you print the same without the implicit n using list comprehension? I'm not completely sure what that question means. Adriana, can you clarify maybe either like speaking up or typing? Can you print the same without the implicit?
So right now I see that it's kind of on a vertical way of printing it, but could you like delete the /n or make it like a
Oh,
horizontal output?
This is actually, this is not a string, right? This is just, let's say I print this. It's probably, see, it was just a formatting thing that Python did behind the scenes.
Gotcha. Thank you.
So this is not a string. If these were like, this is just so it's easier to read. Just some smart output formatting that Python does. It's not a string. There's no new line in here in our data structure.
Thanks.
Okay. So today's exercises, they're kind of like starting out very simple. It covers everything that we did today. There's functions and ifs, there's lists, there's a while loop, there's a for loop, and there's a recursion and a list comprehension. I hope they're not like super complicated. They should take you about like maybe 15 to 20 minutes. Again, you're welcome to like do this, or you should be doing this in a group, in a breakout room right now. If you have any questions, I'll be hanging around, and you can just like call me to the breakout room and I can join in, or any of the TAs can join in to help you out, or you can like type in Slack and we can also help you out there. Any questions before I start the breakout rooms? Okay, here we go.